In the previous lecture, we have been talking about how to calculate Shannon entropy for a given feature. Of course, we are interested in the target variable, so that's why we have to deal with the Shannon entropy of playing golf. Okay, then we have to calculate the entropy with respect to a given feature. As far as the dataset is concerned, as you can see, we have four features: outlook, temperature, humidity, and wind, and we have a so-called target variable whether we are going to play golf or we are not going to play golf. So this is the formula we have to use. We have to find out the probability of the given feature, we have to multiply it by the entropy, and finally we have to sum them up. Let's take a look at the outlook feature. As you can see, there are three possible values of the outlook. The outlook can be sunny, it can be overcasted, and it can be rainy. So this is why we have sunny, overcast, and rainy. And we have the target variable whether we are going to play golf or not. So basically there are two possible values of playing golf, yes and no, and we just have to count the occurrences. So for example, whenever the outlook is sunny, how many yes and no values are there in the play column? So sunny has the value no, sunny has the value no, then sunny has the value no, then sunny has the value yes, and finally sunny has the value yes, which means that there are two yes values and three no values associated with sunny. We have to do the same for overcast, and we came to the conclusion that we have four yes values and zero no values. What about rainy? We have three yes values and two no values. So we just have to use this formula. We have to calculate the probability of the given possible values. What is the probability of sunny? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 values altogether. And we have to count the occurrence of the sunny. 1, 2, 3, 4, and 5. So this is why the probability of sunny as far as the outlook feature is concerned is 5 divided by 14, and we have to calculate the entropy with these values 2 and 3. This is what we have been talking about in the previous lecture, that calculating this entropy we just have to use this simple formula. This is called the Shannon entropy. So the probability times the base 2 logarithm of the probability, and we have to sum them up. So in this case, for 9 and 5, we have something like this. Whenever we have 2 and 3, what do we have to do? We have to use 2 divided by 5, base 2 logarithm 2 divided by 5, minus 3 divided by 5, base 2 logarithm 3 divided by 5. So we have to use the same formula as here, but of course with these values, so 2 and 3. And it has the value 0, 9, 7, and 1. So basically this is what we have to do. What is the probability of overcast? We have 14 values altogether, and we have to count the occurrence of the overcast. So 1, 2, 3, and 4. So this is why 4 divided by 14 is the probability that the outlook is overcasted. And what is the entropy for 4 and 0? It's going to be 0. Plus the probability of rainy. How many rainy values are there in the outlook column? We have 1, 2, 3, 4, and 5, so that's why 5 divided by 14 is the probability of rainy, and we have to calculate the entropy with 3 and 2. Again, we have to use this formula with the Shannon entropy. By the way, if we sum up the probabilities, of course we end up with 1. So 5 divided by 14 plus 4 divided by 14 plus 5 divided by 14 is equals to 1, of course. Okay, so this is how we calculate the entropy with respect to a given predictor or feature. And what about information gain? Information gain is the most important value as far as decision trees are concerned. So first of all, what is information gain? Information gain is the decrease in entropy after the dataset is split on a given attribute or feature. Feature and attribute with the highest information gain will be the root node in the tree. In the previous lecture, we have managed to construct the decision tree, but it is a good question that how do we decide what's going to be the root node? How do we decide whether we have to split a given node or not? This is why we have to deal with information gain. So the information gain, as far as Outlook is concerned, is the entropy of playing golf minus the entropy of playing golf with respect to Outlook. Okay, so we have calculated the entropy of playing golf, which is 0.94. So this is why we have this value. And we have calculated the entropy of playing golf with respect to Outlook, which is 0.6936. Okay, so this is why we use this value, and the result is going to be 0.274. So it is the information gain of playing golf with respect to Outlook. And this is what we have to do with all the features. So for Outlook, temperature, humidity, and wind, and the feature with the highest information gain is going to be the root node in the tree. We just have to calculate this information gain for all the other features such as temperature, humidity, and wind, and we have to choose the one with the highest value. Why is it good? Because if we have the feature with the highest information gain, we know that it's going to be the root node in the decision tree because it is the most relevant feature. So this is how we are able to end up with an algorithm capable of constructing a decision tree. Okay, we just have to check that if an entropy for a given branch is greater than 1, we have to split the given feature. So as far as overcast is concerned, we don't have to split any further. But as far as humidity is concerned, we have to split it into high and normal. As far as wind is concerned as a feature, we have to split it further into true or false. And the leaf nodes are the target variables, whether we are going to play tennis or not. So after constructing the decision tree based on entropy and information gain, we just have to traverse this tree-like structure. If the outlook is sunny and it is windy, then we are going to play golf. If the outlook is rainy, the humidity is high, we are not going to play golf. So basically this is the aim of constructing a tree-like structure like this, because we are able to predict the target variable for given features such as outlook, temperature, humidity, and wind. Okay, in the next lecture we are going to talk about the advantages and disadvantages of decision trees, and finally we are going to take a look at the concrete implementation. Thanks for watching.